In this screencast I will show you how to check and screen your data. Here is the dataset that was used in the Level 5 module Research and Graduate Employment in Sport and Exercise. In the previous video I showed you how the data was inputted into SPSS. To begin I will compute two new variables. Computing variables means combining variables in some form or another. You may or may not need to do this for your dissertation depending on the type of information you collected and the scales you may have used. There were 10 questions about personality in the questionnaire that were used to collect the data. The 10 questions reflect 5 subscales: extroversion, agreeableness, conscientiousness, emotional stability, and openness. You can work out the mean for each subscale by computing the variables. I will compute variable 1 and call it mean extroversion, and then compute another and call it mean openness. If you go to Transform, Compute Variable, and in the target variable box, I'll need to type in the name of the new variable. First you click on the button marked with the brackets, and brackets will appear in the numeric expression box. You will now need to enter the variables extroversion and extroversion 2 in this case. You will also need to ensure that you insert a plus symbol in between both of them. In this case I am interested in the mean, so I'll need to add a division by 2. Therefore I need to click on the / button and put a number 2. If you then click OK and go back to the data view, you'll see at the end there will be a new variable, mean extroversion. I will now need to do the same for the second variable. In this case I want to know the mean for the subscale openness. So again, if you go to Transform, Compute Variable, and put in mean openness as your variable name, delete the previous expression, add your brackets again, and find your variables related to openness. Don't forget to put your plus sign in between both of them, followed by a / and 2 for the division. If you click OK and again go back to your data view, you will see that there is a new variable called mean openness. If you use a questionnaire with a number of subscales, you can use the computing variable option to work out the mean for each subscale, as I have demonstrated. The means can then be used in your analysis. Now we are going to move on to checking and screening your data. Before any analysis is performed, it's important to screen the data. If data is missing, incorrectly inputted, or non-normal, then you will be left with invalid and unreliable results. It is also important to screen your data to ensure that you meet the parametric assumptions. These include making sure there are no outliers and ensuring your variables are normally distributed. For research that looks at differences between means, you will also need to ensure the groups are randomly assigned. You can do this before carrying out your data collection. Data also needs to be interval. Interval data is ranked data, don't forget. For example, a motivational scale or height. If your data is not interval or ratio, then please see the screencast titled Conducting Non-Parametric Tests for more information. But let's get back to screening data. Screening data involves 2 steps: checking for outliers and checking for normality. I will now show you how to screen dependent variables. The dependent variables I will be focusing on are baseline strength, change, and trial 4. One method to check for outliers in the data is to compute Z-scores for each participant on the variables of interest. Z-scores give an indication of how extreme participants' data is. A Z-score is a statistical measurement of a score's relationship to the mean in a group of scores. A Z-score of 0 means the score is the same as the mean. A Z-score can also be positive or negative, indicating whether it is above or below the mean and by how many standard deviations. To calculate Z-scores, you need to go to Analyze, Descriptive Statistics, Descriptives. Within the list of variables, you will need to find the variables you are interested in. In this case, it's baseline strength, change, and trial 4. Once you have found those, you drag them over to the variables box. You then need to tick the box under the list of variables termed Save Standardized Values as Variables, and then click OK. If I go back to the dataset on DataView, there are now 3 new variables: Z baseline strength, Z change, and Z trial 4. 3 new variables allow you to determine if any values are outliers. Taking one variable at a time, you'll need to look through the list and identify any Z-scores that are either above 3 or below 3. As you can see, there are no outliers for any of my variables. There are many suggested ways on how to deal with outliers. The most basic instruction is to remove it by deleting the data point, but do not delete the Z-score. The second thing to do is to check for normality. To check for normality, you will need to look at the distribution of the data to see if it is normally distributed. To do this, you will need to obtain a histogram with a normal distribution curve for your dependent variables. Again, I will be using baseline strength, change, and trial 4. To obtain a histogram, you go to Analyze, Descriptive Statistics, and Frequencies. You then need to select your dependent variables and move them into the variable box. You then click Charts and select Histograms. Click Show Normal Curve on Histogram, Continue, and then OK. In your output file, they will then be generated. If you scroll down, the histograms are now being produced. As you can see, the histograms appear normally distributed, and so it is safe to say the assumption is being met. However, data is never perfectly normal. You need to assess your histograms and decide, with the help of a partner or your supervisor, if the 2 variables look sufficiently normally distributed. Data that is not normally distributed tends to be skewed, with the peak appearing on the far left or the far right of the graph instead of the middle.